In this video, we will do a producer's surplus example. So remember that we talked about the formula for producer surplus in the last video. It was this integral formula. So we're going to do an example where we compute that at some point in this problem. Okay, so this question says that a local Taco Bell's demand equation for its new mini taco is P equals 1,000 over 3Q minus 3, where P is the unit price in dollars, and Q is the number of mini tacos sold per hour. The franchise is prepared to sell Q equals 9 times P plus 3 squared mini tacos per hour at a price of P dollars each. Okay, so there's these two equations that it's giving us. And it tells us one of them is the demand equation. All right, part A asks, find the price they should charge to sell as many mini tacos as possible without having unsold ones. So this is actually a review question in some sense from Math 30. So what I want you to do is pause the video for about 1 minute to see if you can identify what is the key idea that I would need to answer part A. There's kind of a key idea for what this is saying. 4, 3, 2, 1, pause the video. Pause it for 1 minute and see if you can determine what is it talking about when it says they want to sell as many as possible, but without having unsold ones. All right, so hopefully you did that. Hopefully pause the video for about 1 minute to try to think about this. So what this is saying is that they don't want to run out of tacos on one hand. So they don't want a shortage, no shortage. But they don't want to have tacos that just didn't sell, unsold ones. So that means they don't want a surplus, nor a surplus. And that happens at equilibrium. And that was one of the concepts when we learned about supply and demand from early on in Math 30. But what we need to do as review to find equilibrium is this happens when the demand equals the supply. That's that sweet spot that gives us no shortage and no surplus. All right, so we are going to need to set the demand equal to the supply. So let's remind ourselves what both of those equations are. So the problem told us the demand equation. It said P equals 1,000 over 3Q minus 3. The problem also told us some other equation. It didn't specifically tell us it was the supply, but we can get that from the context. It's talking about how much the franchise is prepared to sell, which is referring to how much the franchise would be willing to supply and make available for sale. All right, so let's write this down underneath demand. So let's write our supply. Okay, so the supply was that other given equation. Q equals 9 times P plus 3 squared. Okay, so we know we're going to need to set the demand equal to the supply, but we need to be careful because in the demand equation, this is P equals some stuff. But in supply, it's Q equals some stuff. But if we want to set two things equal, it's got to be the same variable. Like we have to either be setting like two y's equal to each other or two p's equal to each other. It's got to be the same thing that we're setting equal. So in this context, when we set these equal, we either need to be setting Q values equal to each other. So there's a Q that comes from the demand, and I could be setting that equal to the Q that comes from the supply. Or I could isolate P in both of them and get the P that comes from the demand and set that equal to the P, the price that comes from the supply, and set those equal. Those are my options here. So in one of these two equations, I'm going to have to isolate for the other variable. So either in demand, I'll have to isolate the Q. So I could set the two Q's equal to each other. Or in the supply equation, I could isolate the P and then try to set the P from that supply equal to the P value from the demand. Okay, so I think it's going to be a little bit easier to isolate Q from this demand equation, because if I were to isolate P from the supply, I see that at some point I'm going to have to square root to get rid of this squared. And I prefer not to have a square root if possible. Okay, I just think in terms of the algebra, it's going to be easier not to have that square root. Alrighty, so let's rearrange this a bit to isolate Q. If I add 3, I get P plus 3 equals 1,000 over 3Q. And now, if I rearrange a little bit more, I'm going to multiply 3Q to the left and then divide by P plus 3. So I'll divide that P plus 3 over to the right. So this equals 1,000 over P plus 3. And now we're almost there. Now I just need to divide that 3 that's with the Q. Oh, whoops, sorry. No equal sign. This should be an arrow. Arrow. Q equals 1,000 over 3 times P plus 3. So when I divide by that 3, it goes to the denominator. Alrighty, so now I have both of these Q's isolated. I have the one from the supply and I have the one from the demand. So we're ready to set them equal. Okay, so we are ready to now set the Q from the demand equal to the Q from the supply. Alright, so the Q from the demand was 1,000 over 3 times P plus 3. And the Q from the supply was 9 times P plus 3 squared. Alrighty, so if I rearrange this a little bit, let's get everything with a variable on one side. So if I do that, I'm going to take this P plus 3 that's here on the denominator, and I'm going to multiply it over to the other side. So that'll give me P plus 3 cubed when I multiply it over to the right. And then the 9 that's on the right-hand side, let's divide that over to the left. So that would give me 1,000 over 3 times 9, but 3 times 9 is 27. Okay, so getting simpler. But one really nice thing that happened here was I had these common P plus 3s. That made this a nice P plus 3 cubed. Okay, so at this point it's just an equation from algebra. I could get rid of that cubed by cube rooting both sides. So let's cube root both sides. And the cube root of 1,000 is 10. Cube root of 27 is 3, so that's really nice. On the right-hand side, I'll get P plus 3. When I take an odd root of both sides of an equation, we do not need to put a plus or minus. But if I was doing an even root on both sides, we would need a plus or minus. All right, so we have this. And then if I isolate for P, we get P equals 10 over 3 minus 3. And if I get a common denominator, 3 is 9 over 3, which gives me 1/3. So 1/3, and what are the units for P? This is price, and the problem said price was in dollars. So that is my answer to A. It wanted to know the price that would give us at which we'd reach equilibrium, and we found that price. It's 1/3 of $1. So let's move on to part B of this question. So B, find the producer's surplus at this price. All right, so let's begin by reminding ourselves, well, what was the equation for producer surplus? It was PS, producer surplus, equals integral from 0 to Q bar of, P bar minus S of Q, the supply function in terms of Q, dQ. Okay. So I know I'm going to need to get Q bar. That's my upper limit of integration. So let's maybe begin by doing that. Let's get Q bar. So I know what the price is, because the question said find the producer surplus at this price, meaning the price that we just got in part A, which was 1/3 of $1. So that's my P bar. P bar is the price that they are charging. Okay, that is 1/3. And I need to use that to get Q bar. Okay. So because this was an equilibrium price, we can plug this into the demand or the supply, since this is equilibrium. At equilibrium, the demand and the supply, the value of Q for both of them, is supposed to be the same at this equilibrium price. Okay, so that's nice. So I can choose which one to plug into. I'm going to plug into the supply equation because it's already in the form Q equals something, except I'm going to call this Q bar now, because when I plug in a third into it, it'll tell me Q bar. So Q bar is equal to 9 times, I'm going to plug in my number. I'm going to plug in the 1/3. 1/3, and it was plus 3 squared. That was my function, plugged in a third. Simplifying this is 9 times 10/3 squared, if I just get a common denominator. So 10/3 squared, that is 100 over 9. And that's kind of nice. 9 times 100 over 9, that is 100. So that's Q bar right there. Q bar is 100. Alrighty, so next, so to use this formula, I need, I know P bar, I know Q bar. Do I have S of Q? Do I have my supply function in terms of Q? Well, if I look at my supply equation, this is in terms of P right now. I have Q equals a function of P. But that's not what I want. I need P isolated and to have it as a function of Q. Okay, so we're going to have to do a little bit of algebra. We are going to need to get the supply in terms of Q. So to do that, we are going to need to isolate P in that equation. So we're going to get P equals some stuff in terms of Q. Alrighty, so let's scroll down and give ourselves some room here. So the equation, our supply equation, is Q equals 9 times P plus 3 squared. So let's isolate the P. So first I'll divide by 9 and get Q over 9 equals P plus 3 squared. And then I could square root both sides. So that'll give me Q over 9 in a square root equals, on the other side, P plus 3. But anytime I square root both sides of an equation, I need to put a plus or minus on one of the sides. Okay, so I can isolate the P now by subtracting 3. And if I do that, I get P equals, if I square root this thing, on the top I'll get square root of Q. On the bottom, square root of 9 is 3. And I've subtracted the 3, subtracted this other 3 over to the left. And technically, I don't need to write the negative in front of the root. There's a reason why it can't be the negative root. And one of the ways I can see that is I need the positive square root, because this is supposed to be my supply graph. And with the positive root, my graph is going to be increasing. So I need the positive square root to be increasing. So I would encourage you, if you don't quite see why it's increasing, to plug this in to a graphing calculator and convince yourself that it is increasing. If we had a negative in front of the square root, it would be decreasing. And a supply graph in general typically is not going to be decreasing. Okay, so now I know what P is in terms of Q, which means this is my S of Q. It is supply as a function of Q. So we are ready now to finally compute our producer surplus. So our formula for that was producer surplus equals the integral from 0 to Q bar. Q bar was 100. And then we put P bar first, which was 1/3, minus S of Q. So S of Q I'll put in parentheses. That was square root of Q over 3 minus 3 dq. Okay, and from here, this integral is actually not too bad to do. So I'm going to do it quickly, because we've done the heart of the problem, which is kind of all the setup. Once we've set up the integral, we've been doing integrals like this for a few weeks now, so I'm going to go more quickly through it since we've done a bunch of integrals now. Okay, so we'll get 0 to 100. When I distribute this negative sign, I'll get a positive 3, and if I add that to the 1/3 in front, we'll get 10/3. And then I'll get minus 1/3 square root of q, which I'll rewrite as q to the 1/2 dq. And now this is easy to do the antiderivative of. So antiderivative of 10/3, that is 10/3 times q. And then for the next term, we have minus 1/3 times, so for the antiderivative of q to the 1/2, this is reverse power rule. I add 1 to the power and I get q to the 3/2. And then I would divide by this new power, which is the same thing as multiplying by the reciprocal, 2/3. All right, and then I need to plug in 0 into this and 100 into this. Okay, so from here, it's just some plugging in and subtracting. So I'm going to skip that part, the plugging in and subtracting, and just tell you what you end up getting. So when you do this, you'll end up with 1,000 over 9, and the units in this question for our dollar, sorry, we're dollars. Okay, so 1,000 over $9. That's our producer surplus. Okay, so what I want to end this video with is a comment about this. So a comment about these surpluses, producer surplus and consumer surplus, which we talked about before. These surpluses are sort of extra money in people's pockets, either in the consumer's pocket or the producer's pocket, but extra money in people's pockets is a good thing. It is good. And that is one of the reasons why we're interested in measuring it. Just how much of this good thing do we have? Okay, and I want to end now with a definition. So we call the total social gain. We're going to let that be the sum of the consumer's surplus and the producer's surplus. So if you add those two surpluses, it's sort of the collective benefit to everyone, to the consumers and to the producers, and that's why it's referred to as the total social gain. Alrighty, so in terms of our goals for this section, we have finished our last goal. Now that we've talked about producer surplus, we did an example where we computed it. That involved finding an equilibrium first. So remember, this was just part 1 of section 7.4. Next time, we'll get into the second part of this section, which talks about income streams.